Welcome back, guys. We're going to kick off Pythagoras this time. And the beauty about Pythagoras, it is only dealing with right-angled triangles. Um, so here we have right-angled triangle, and just to kind of label the different sides, the hypotenuse is always the diagonal, is always the longest side of the triangle. Okay, and this is represented by C. Then on the other sides, we've got side A and side B. Now, it doesn't really matter which one's side A or side B. The most important thing is to note that the diagonal, or the longest side of the right angled triangle, is called the hypotenuse. That is always C. Okay? And there's a rule. A squared plus B squared is equal to C squared. And this, I guess, with Pythagoras, really hoping that you guys are going to familiarize yourself with algebra, linear equations, solving for an unknown. It really depends on all of that, as well as your understanding of measurement. So if you need to go back to previous chapters and to revise over those things, that is something that I would highly recommend. Okay, so the whole idea of this is that when we've got three sides, we need to work out what one side is based on knowing what the other two are. And I might just go through and just jump in with a few questions, so it will just help you understand what's going on. So let's start off with something like this. Okay, so here's a triangle, and I want to know what C is, and we know that this is a 3 and this is a 4. Okay, so what do? Throw it into our formula, where C squared is equal to A squared plus B squared. Okay, A is 3 and B is 4. So 3 squared plus 4 squared is equal to C squared. 9 plus 16, and C squared is equal to 25. Now, how do we get C on its own? We don't want C squared, we just want C. So the opposite of squaring is square rooting, okay? So you need to square root both sides. The square root of 25 is 5, okay? So what we have here is that this side is a 3, this side is a 4, and we've just worked out that this side is 5. Okay, so that's working out the hypotenuse. Now, let's say we wanted to work out another side of the triangle that's no longer the hypotenuse. So we'll just draw this triangle here, and this is a 10, this is a 16, and this is an x. Okay, we can still work out the work it out through our formula. C squared is equal to A squared plus B squared, and we just substitute the values in. Okay, so gonna call that A, gonna call that B, and we're calling this C. So 16 squared is equal to 10 squared plus B squared. All right, now to work out all of this, you could say that B squared is equal to 16 squared minus 10 squared. And 16 squared is 256. 10 squared is 100. So B squared is equal to 156. Okay. And remember, how do we get B on its own? We square root both sides. Okay, so the square root of 156 is, and I'm just going to round it off to one decimal place, 12.5. So it's not quite a perfect square, but at this level, you'd be expecting things not to be perfect, but you might be using it in exact values. So you might be incorporating surds, or you might be incorporating in decimals. All right. Okay, so I'm going to do one more. And that's not working. That'll do. And so we've got a right angle triangle here, 5.2 meters. And then we've got 80 centimeters. We're wanting to work out what this side is. No different to anything else, but the thing that we need to make sure is that the unit of measurements are the same. We can either convert them both to meters, or we can convert them both to centimeters. Doesn't really matter. We know that there is 100 centimeters in every meter, so let's make this 520 centimeters, okay, just to work with whole numbers. So if we substitute everything into our formula, we've got 520 squared is equal to 80 squared plus f squared, okay? And 520 squared is a very, very big number. So now this is where you need to use your common sense, whether converting to centimeters or converting to meters is going to be better for you. In this case, we can see that converting it to centimeters, you're only dealing with bigger numbers. Yes, you are avoiding using decimals, but I guess that's the sacrifice and the thing that you need to make the decision for yourself, unless the question asks you specifically what unit of measurement to work with. Okay, so 80 squared is 6400. And we've got that. So 270,400 minus the 6,400 leaves you with 264,000 centimeters. Okay, and we want to get the square root of that. To get f on its own. Okay, so let's work that out. 264,000, and the square root of that is 513.8. And we're dealing with centimeters. Okay, now you would get to the same point if you were to convert both to meters. Obviously, in this case, we could say 5.14 meters. Okay, all right. Hopefully that makes sense to you guys in terms of just introduction to Pythagoras, the different sides of the triangle. We're going to move on in the next video with a bit of application and looking at different other scenarios where we can apply this. All right, see you in the next one.